Hello everyone. So today we're going to continue on our last example from 13.1. So if I remember correctly, at the end of last video, we are trying to test out this formula right here on the screen. So we pick an example that we have done before, which is this one, dx over dt equal to 1141xy. We already know the eigenvalue of 3 and -1 with the corresponding eigenvector of 1, 2, and 1, -2. And based on that, we know the general solution come out to be c1 e to 3t times 1, 2 plus c2 e to -t times 1, -2. And I gave a initial condition, which is at t equal to 0, the x is 2 and y is 3. And using that, we found out that our solution subject to the initial condition is given right here, which is x equal to 7 over 4 e to 3t plus 1 over 4 e to -t, and y is equal to 7 over 2 e to 3t minus 1 over 2 e to -t. Now the question is, if I go through this process, would I get the same result? One of the nice things about using this process is once you have all the matrix set up, you could easily use your calculator to help you do the matrix multiplication as well as forming inverses and stuff like that. So that actually cut down on a lot of the work that you need to do, and it make it very easy to use your calculator to come up with a solution once you kind of get some of the information that you need. So show you how it's done. So here, first of all, I'm going to form my matrix U. My matrix U would have to be 1, 2, 1, -2. And with that, I have our corresponding lambda t, which since I use 1, 2 as the first column, I have to use e to 3t because it's the corresponding eigenvalue 3. 0 here, and e to -t. I do need to find U inverse. So since it's a 2 by 2 matrix, it's pretty easy to find the inverse. So it'll be 1 over -2 minus 2, which is -4. And then, if I remember correctly, it's d -b -c a. And so this come out to be 1/2, 1/4, 1/2, -1/4. So that's my U inverse. We also know that our vector x sub 0 is actually 2, 3 based on our initial condition. And since we are using 0, I don't have to do any translation. So that's everything I need. So that means our solution, vector x, should equal to 1, 1, 2, -2, multiplied by e to 3t, 0, 0, e to -t, multiplied by 1 over 2, 1 over 4, 1 over 2, -1 over 4, and then the vector 2, 3. So it's just a matter of multiply all of this stuff out and get an answer. So let's go and do that. So I'm going to go and slowly multiply them out. So I'm going to first start by, like, let's say these two. So if I multiply this, there will be 2 times 1/2 plus 3 over 4. So 2 times 1/2 is 1, plus 3 over 4 is 7 over 4. And then 1/2 and -1/4 times 2, 3. There will be 2 times 1/2, which is 1, minus 1/4, which is 1, minus 1/4, which is minus 3/4, which is 1/4. All right, now I'm going to multiply these last two together. So we'll keep 1, 1, 2, -2. So that's actually pretty simple. That just becomes 7/4 e to 3t and 1/4 e to -t. And now when I multiply this together, I will get this. Vector x is equal to 7 over 4 e to 3t plus 1/4 e to the -t. And then 2 times 7/4 e to 3t, which is 7 over 2 e to 3t. And -2 times 1/4 is -1/2 e to -t. Notice that is the exact same answer as what we have right here. And I don't have to solve the system of equation, and I don't have to I don't have to write this out either. I can just multiply all this stuff together, and now voila, I have an answer. So that's pretty neat, I have to say. Now, how about the same exact question? What if we change the initial condition to this? So now notice that because I'm using 1, that actually make this system a little harder to solve, because I will have the e to 3t, which is e to the third power, and e to -1 power in our system. That would just make for this system to be a little more messy when we do it. But notice what we're going to do right here. We actually going to do the following. So what is the solution in this case? It will be this. Ready? It will be just 1, 1, 2, -2 times our lambda matrix would change into e to the 3 times t minus 1, 0, 0, e to negative t minus 1, multiplied by the inverse matrix, which is 1/2, 1/4, 1/2, -1/4, and then multiplied by our vector x sub 0, which is 3/4. Now, you should not have any issue multiply all of these together. So I'm not going to do it. I'm going to ask you to do that yourself. And I'm going to just simply write out the solution for you. So I would suggest that you pause the video right now and see if you can go through the multiplication here from beginning to end, just like what I did right here, to see if you can come up with the solution right here. Okay, pause your video, and once you're done, you can continue to watch, because I'm going to write out the solution now. So the solution, vector x, will actually equal to this. All right, and there you go. That's the answer. Pretty much after I multiply all of those things together, that's what I got. The important or the interesting thing about this process is that it allows us to turn solving a system of differential equation with constant coefficient a, provided that it doesn't have any repeated eigenvalue and all the eigenvector are linear independent. It turns solving the system of differential equation into a very basic algebraic process. All you have to do, find the eigenvalue, find the eigenvector, form the three matrices, matrix U, matrix lambda T, matrix U inverse. If you have an initial condition, then you can plug in x sub 0. If you don't have an initial condition, then you don't even need U inverse. You just introduce the vector C to take the place of the arbitrary constant. And then all you have to do then is just a whole bunch of matrix multiplication to allow you to come up with the solution. So this is a very mechanical way to deal with solving a system of differential equation without any really thinking involved. It just basically just form all these things that you need and then just multiply them together and you get an answer. All right. So what I want to do is, I guess what I want to do is probably go over a few more examples with you just to make sure that you can do this. And then that will be it. So this is, I believe, our 4th video. So if I finish all the example I want to show you, then you won't need a 5th video, and that will mean that we have an extra day that you can actually do your own work, catch up on your videos, and maybe ask some questions. All right. So next problem is this one. dx over dt equal to 3x 2y. With initial condition, vector x of 0 equal to 0, 1. Okay, solve the system using eigenvalues and eigenvectors. All right. So pretty straightforward. Let's go for it. So in this case, first of all, I'm going to make sure I form my matrix first. Oh, actually, maybe I should write it this way. All right. So let's find an eigenvector and eigenvalue. So that would mean that determinant of A minus lambda I equal to 0 would turn into 3 minus lambda times 2 minus lambda minus 0 times 0 equal to 0. So that simply indicates lambda 1 equal to 3 and lambda 2 equal to 2. Yeah, because just 3 minus lambda times 2 minus lambda equal to 0. So therefore, just 3 and 2. Okay. Now let's try to solve for the eigenvector. So let's say lambda 1 is equal to 3. So therefore, what I have will actually be 0, 0, 0, negative 1 times uv equal to 0. Note the first equation just says 0 plus 0 equal to 0, so that's completely useless. The second equation tells me that negative v equal to 0, that implies v equal to 0. So therefore, I'm going to go ahead and say that our eigenvector, u1, will be just 1, 0. Technically speaking, you can put 2, 0, 3, 0, pi 0, or any number as the first number, as long as you have the second number equal to 0. So I'm going to say, I'm just going to make it simple and just pick 1 as the first number. So that's because it makes the multiplication easier. Okay, now let's do lambda 2 equal to 2. So when I do that, I have 3 minus 2, which is 1, 0, 0, 0, uv equal to 0, 0. So that just tells me u equal to 0. So once again, in this case, I am going to say, so I just need u to be 0. V can technically be anything. So once again, I'm going to be simple and just pick 1. So now I'm ready to go ahead and solve this problem. Okay, so let's do this. So our vector x would actually, yeah, I can write it. Is u lambda t u inverse vector x sub 0. So let's see what we do know. What is u? U would actually be 1, 0, 0, 1. Lambda t would actually equal to e to 3t, 0, 0, e to 2t. Here's interesting. What is u inverse? Well, notice that u is actually the identity matrix. So what is the inverse of the identity matrix? What do you think? What do you think when you multiply identity matrix with what would always give you the identity matrix back? Well, guess what? Identity matrix is its own inverse. And we do know that vector x sub 0 is 0, 1. So now I'm going to construct my solution. My solution is going to be 1, 0, 0, 1. E to 3t, 0, 0, e to 2t, 1, 0, 0, 1, 0, 1. Now, because of the fact that both u and u inverse are identity matrix, they are just kind of fall off. So therefore, that just becomes e to 3t, 0, 0, e to 2t, multiplied by 0, 1. So I'm going to say that imply that vector x is equal to 0 e to 2t. That's my solution. All right. So that's pretty good. All right, let's see if we can do another problem. And this will probably be a last problem for 13.1. So we finish this problem, then that will be it. That would be, I believe this is our fourth video, and then I don't need to make a fifth video. But I did a plan for 5 days of videos for this section. So that means that we actually had one day. So you have an extra day to just catch up on stuff. All right, so this is the problem that we're going to do. All right, so let's see if we can do this. So once again, let's try to find the eigenvalue and eigenvector. So the eigenvector, okay, I guess solve, you know what I mean. What I'm going to do is solve with by eigenvector, eigenvalue. Okay. So let's go for it. So here's my eigenvalue. So that become, my matrix is actually 3 minus lambda, 5, 3, 1 minus lambda. The determinant equal to 0. So therefore that turns into 3 minus lambda times 1 minus lambda, minus 15 equal to 0. So let's hope this comes out to be some nice number. So it's lambda square. Minus 3 minus 1 is minus 4 lambda. Plus 3 minus 15 equal to 0. So that seems to be lambda square minus 4 lambda minus 12 equal to 0. So that's pretty good. So that's lambda minus 6 and lambda plus 2 equal to 0. So therefore we have lambda 1 equal to 6 and lambda 2 equal to negative 2. So that's the first thing we find out. So that's pretty good. Now let's do eigenvector. So lambda 1 equal to 6. So then my matrix would actually become negative 3, 5, 3, negative 5 times uv equal to 0, 0. So therefore that implies negative 3u plus 5v equal to 0. So I guess I'm going to just say vector uv is equal to 5, 3. So that will be negative 15 plus 15. So I'm going to say vector u1 is equal to 5, 3. So that's my first set. Lambda 2 is equal to negative 2. So therefore become 5, 5, 3, 3 uv equal to 0, 0. It's 3 minus negative 2, so it's 5. And 1 minus negative 2 is 3. So therefore become 5u plus 5v equal to 0. So I'm going to say uv equal to 1, negative 1. So vector u2 is 1, negative 1. So that's pretty good. So now we get both of these. So now we're ready to actually solve for our solution. And all I have to do is simply multiply some matrices together. So therefore, the formula is this. So let's see you have everything. So I'm going to say our matrix U is 5, 3, 1, negative 1. Our lambda sub t is equal to e to the 6t, 0, 0, e to negative 2t. Our U inverse would actually equal to, let's see, 1 over 5 times negative 1 minus 3 times 1. So it's negative 5 minus 3, which is negative 8. And then, if I remember correctly, is negative 1, negative 1, negative 3, 5. Let's see. Always have to double check to make sure I did the right thing. So let's see. Switch these two and negate those two. So is that what I did? I switch these two and negate these two. So yeah, that's it. So therefore, this come out to be 1/8, 1/8, 3/8, negative 5/8. And what is our vector x sub 0? That would be, what did I say it is? 2, negative 1. So now it's just a matter of writing them out. So that would be 5, 1, 3, negative 1, multiplied by e to 6t, 0, 0, e to negative 2t, multiplied by 1/8, 1/8, 3/8, negative 5/8, multiplied by 2, negative 1. So just a matter of slowly multiply them together. So multiply these two together, there will be 2/8 minus 1/8, which is 1/8. And that will be 6/8 plus 5/8. So that would be 11/8. And now multiply these two together. That become 1/8 e to 6t and 11/8 e to negative 2t. Along with 5, 1, 3, negative 1. So now I can finally combine these two together and I have my answer. That will be 5/8 e to the 6t plus 11/8 e to negative 2t. And 3/8 e to 6t minus 11/8 e to negative 2t. And that is our solution. Alright, unfortunately that's the last example that I have for you guys, and that is it for 13.1. So I'll talk to you again soon in our next video or tomorrow during class. Alright, talk to you later. Bye bye.